Now, harmonics theory, does that go back over a good period of time? Is that something that's been developing over many ages and things like that? I mean, we're comparing it to very modern concepts.
No. When I first put it forward was the late 80s.
Mm-hmm.
And I first talked about the foundation of the study of cycles in 89. And there's been some further development, but a lot of the stuff that I came out with the predictions was when was on the forums.
So when you say harmonics theory, are you speaking of a school of thought? Are you referring to your works?
My work. The harmonics theory is, the single axiom of it is this. The universe consists of a standing wave structure, which we can say because of non-linearities of physics, develops harmonics. The waves develop harmonics.
Yes.
Each of those becomes a standing wave structure of its own, and it develops harmonics of its own.
Yes.
And you keep repeating that process. Now, in standard physics, harmonics are well known, right? You know, you pluck a guitar string, there's harmonics there. Harmonics occur in anything where there's a little bit of non-linearity, you get the harmonics. What's unique about the harmonics theory is it says those harmonics become the seeds for new harmonics. Now, in a one-dimensional thing like a guitar string, you can pluck it all you like. You'll get harmonics, but you won't get harmonics of harmonics. Okay?
Right.
But when you get into 3 dimensions, a different thing happens. If you think of it as things getting squished and expanding and that, or vibrating, in 3 dimensions, you get a compounding effect. Because if you're getting this happening, if you make the density go double in each direction, you added one, but you didn't. You ended up with 8. You went times 2, times 2, times 2. So you didn't go the 1 plus 1 plus 1 plus 1 make 4. You got to 8. So it has a compounding effect. You're squeezing something that's already squeezed in the other dimension, so the effect becomes greater, and or rarefactions as case may be. So when you consider the waves that are happening in it, it forms a new wave that has a new centre that's more energetic than the simple harmonic. It becomes its own energy, and over a period of time, as energy moves from the larger waves to smaller ones, they become strong enough to then, well, they're always doing it, but to a noticeable extent, to be able to produce harmonics of themselves. So that's what's unique in the harmonics theory, is the harmonics of harmonics. As far as I know, no one ever entertained that idea before.
Seems to make sense, though.
Yeah, yeah. Well, the proof is in the pudding, and when you calculate it out, the first thing that you get when you do the first harmonics is you get the major chord appear. A little bit further on, you get the whole musical scale appear. And then when you examine it all, it's got exactly this common many ratios of 2 and 3 of cycles, exactly what Dewey found in the common cycles, and which people continue to find in other areas of study. The geological cycles, when I looked up about geological cycles, I found a book called Megacycles. It talks about a 600 million year cycle in geology, a 300 million year, 150 million year, 74 million year, and 37 million years. Quite clearly, though, these ones are a little more accurate than that, and the sequence really should be a little less than 600 in those, but they were doing it to how much they knew. And quite clearly they had a series of doublings. In the studies of the Sun, a number of guys have got peer-reviewed articles published that say there's a 154-day cycle in the Sun. There's also a 77-day one, and a 51-day one, and a 25 or 26-day one, which is a solar rotation. Ratios of 2 and 3 again, and there's some longer ones and other ones, and I can show that those appear in many other things as well, as the Sun. Those are in peer-reviewed journals, and these guys have noted they seem to be harmonically related, and that incidentally merges into the one that Dewey couldn't get to fit to the table, one of the ones that Dewey couldn't get to fit to the table, and when you put a ratio 7 it does fit to the table. And so the whole structure there of the common cycles that Dewey found and the common cycles found by these guys of the Sun in a number of different phenomena, they come, or at least half a dozen different phenomena that are measured from the Sun, these cycles show up. Yeah.
Indeed, and that's the fundamentals of the universe.
Yeah, yeah.
It's fascinating.
Yeah. So I think that's probably enough for that, but it's there at the base of the other things we will talk about to understand that this idea, what we have to realise is that every point in space all these waves are passing through all the time. From oscillations of more than 100,000 million per second in your protons and neutrons, up to one oscillation in 14 billion years at the universal sort of, at the Hubble scale, and all the things in between. Those waves are passing through every point, every moment, the flux of them. But because of the harmonic relationship, you get a thing that happens where super big events happen more often. You remember the old ruler? Oh, you possibly still have them, with inches.
Yeah.
And then there's the half inch, and then the quarter inches, and the eighths, and the 16th, and then you keep making them smaller.
Yeah.
So you've got this pattern of different size spikes on it, right?
Yeah.
We use millimetres these days, and they're doing them in 10, you see. But when you have that sort of a ruler,
yeah,
that's got a rhythm, because it's got, there's the one,
yes,
there's the double frequency, the halves, and then the quarter. And the heights of those things give you a measure of the energy that's happening. You've got that little 16th one that's going tickety, 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 tickety the whole time, and you've got the eighth that's going tick, 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 and you've got the quarter that's going you've got the half that's going bang, bang, and you've got the one that's going crash, crash, and they're all happening together. But in actual fact, the one that does the 12th and the 24th, that's happening as well. There's a lot more there happening. So you get a real musical thing that's going boom, diddy, boom, diddy, boom, diddy, boom, diddy, boom, diddy, boom, 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 and that's happening. Those things are happening, and I think Fred Hoyle, in the later stage of his life, talked about mini Big Bangs. He was, I think, starting to cotton on to that, but there are these cataclysmic events that happen. History, in geology and other things, there are these times when a whole lot seems to happen in a very short time, and that's when these things come together.
A confluence of rhythms, and peaks, and
and we see it in the economy as well. You know, things are going along, puttity pat, you know, dum dum dum, and then suddenly crash. Where did that come from?
1929.
Yeah.
Catch everybody by surprise, which maybe it wouldn't if we understood the cycles of history.
Yeah.
Wow.
And they are predictable.
Yeah.
You know, the Dewey cycle in the 60s predicted that 87 crash, and I predicted an 86 using my own data, and his one would have worked from then, from way back there, which is quite spectacular, really. Yeah.
Remarkable. So we understand waves. If we understand the patterns of waves and how they are replete and repeating themselves on things great and small, we have a key to the fundamentals of the universe.
Yeah. And every point in the universe is not the same. These waves that I mentioned of the stars, 4.43 light years, etc., and the other ones, our star is a type of star that occurs on the 4.43 wave. Bigger stars will only occur on every second one of those at 8.9 light years apart, right? So the Sirius is one of those. Some other stars will occur on a different wave, or in some directions you will find waves which are 5.93 light years, and other ones. There's other measures as well. And so depending on where you are, the planets that form around a star may be using harmonics of the wave it's on, and so they won't all be the same, but they will have harmonic relationships from our system to another system. So you don't expect every star to be the same, but you will expect some stars to be very similar.
And just as the same thing with the planets you were explaining, because some of them will respond to some of the frequencies in the sun, and other planets further out, other frequencies in the sun, but not every sun is the same. But there's maybe a finite, a somewhat finite number of frequencies to which the suns will gravitate towards.
Right.
So they're there. So we have tendencies to exist. And we have consistencies in the tendencies to exist, even though existence itself is not consistent.
And we will do a talk about the fact that the bigger wave that makes the outer planets and the smaller wave that makes the inner planets is harmonically related over many orders to the frequencies of the particles, and does constitute the fact that those ones are made of hydrogen and helium and these ones are made of other stuff.
Many things at play at one time. That's why we don't often see them.
And we'll see connections over things there that people hadn't even noticed. But when you notice them and show them, people tell me, oh, it's just a coincidence. And I love that. I laugh. I've got a lot more coincidences. Do you want to hear them?
But they're not, once we understand the elements. If you have a drummer playing one drum beat, another drummer playing another drum beat, and another, but the beat of each drummer is different, and you have them playing all at the same time, it's going to sound like a syncopated cacophony. Yet, the fact is, what's making all of that noise and what seems to be unpredictable patterns is a very consistent beat from each one of those drummers.
I've chatted to some of these guys, and a number of musicians come across my stuff and quote it. And they pick out nice little quotes, so I know which are the good quotes.
Yeah.
And but one of the guys said, we have a set of drummers and we do different rhythms, you know, so one might be going twice as fast as another, one might be going 3, and they might have all different ones. And he said, eventually you all come together again. And I said, and he said, how do you sit when you're doing that? Oh, it's funny, he says, you sort of sit down and it doesn't feel quite right, and you move around till it feels right. And I said, yeah, measure those distances and work out what frequency you're playing. And what's the wavelength of that? Because like sound travels 1100 feet per second.
Yeah.
Work out what frequency it's playing. Work out the wavelength, and just see if you happen to be sitting that far apart. He said, "Oh, I think that's what we're doing."
There you are, frequency and distance again.
Yeah, yeah.
So things are interconnected, even when they don't seem to be.
Yeah, yeah.
Well,
people know that they do this moving about. They're not sure why.
Yes.
And they're actually getting themselves perfectly synchronized. It's like that's the way atoms arrange themselves. You can get a bunch of atoms, but they like to form a crystal, right? Where they're all at the correct distances from each other.
Well, interviewer Bill Moyers said to Joseph Campbell one time that we're all dancing to the music, even when we can't name the tune.
Yeah, yeah, yeah. And that's one of the things I tell astrologers is, yes, there are connections between life on Earth and the motion of the planets, but they don't. I used to think that they caused things in the sun that caused us, but now I know that those same ones exist in other parts of the universe, and it's a universal waves that drive the planets and drive us all together.
Fundamentally.
Mm. So we're all dancing to that same universe here. But some of us are tuned slightly different, so we pick up different parts. You know, when you have one commodity, like when you have these cycles of produce, to get the swing happening, to go too far one way and then too far the other way, and how much they produce, and therefore that affects the price, it's how fast can they react. If you grow something and it takes 5 years to produce, you can't have a 2 or 3 year cycle in it. Right?
Right.
You've got to have a long cycle. But if you make something that's turn over very fast, annual crop, you can have a 3 year cycle in it or a 5 year cycle. And so things that take longer to produce will have 7 or 9 year cycles. Things that are faster will have 4.5 or 3 year or whatever cycles in them, you know.
Yes.
So they're tuned. It's the old wine glass and the singer thing, right? You've got the wine glass, you sing the right note.
That will shatter.
Now the universe is singing many notes. And different things will pick up. It's like a radio, you can tune it to different frequencies to pick up which one you want. If you've got a very crudely formed radio, it will pick up multiple stations at once. So you will actually have multiple things going. And most systems are crude radios, they will respond to multiple frequencies.
That's true. And if you look at the musical instrument from India, the sitar, where we have a lot of ancient knowledge, understanding kalpa, which is cycles, and the relative universe rather than the absolute universe. For instance, Kala is the relative world and all the cycles within it, which is how they define it. And the Mahakala, which is one of the 108 names of Shiva, is transcendentine and absolute, not relative. And they represent this in the sitar, which has 7 main strings on the top, yet underneath, in the hollow of the neck, is many small strings called sympathetic strings. Those strings are never plucked.
But they vibrate.
They vibrate based on what notes are being played on the strings on the top.
And so they will carry on when you change something else on there.
They continue on, and they develop this drone, but the drone is going to wind up matching. So it's a sympathetic vibration that's going on. And they say that represents the substratum of the universe, the sympathetic strings, nice, while the strings on top, they represent the relative world in which we live.
You'll get that on the piano. If you put your foot down to the pedal down, when you play much, you'll hear other ones picking up that as well.
Yes.
The old bagpipes have one note drone that they keep going the whole time, don't they?
Yes, they do. Yes, they do. And a pedal point was sometimes used by Bach and other Baroque musicians with the organ. They would actually jam a piece of wood and they hold one note steady while they keep playing around that.
Yeah.
You know, So the examples are replete, but why do we do this so many times? Well, because we're finding it in the substratum of the universe are these elements, and we're sympathetically vibrating to them.
These cycles in the universe, and are harmonically related, it's very much music, right?
Yes.
And a number of the famous composers have said, I don't make this music. I just listen and it's there and I pick it up.
Yes.
So they've got this ability to tune in somehow, and they put it down, and it's and you can see it's there. And the best ones, there's certain things in them, which is we'll do music as a separate subject, but there's certain things in them that show that they are in tune. The rhythms they use are harmonically related in the way Harmonics Theory said they should be to the notes they're playing, which are much higher frequency. The rhythm can be thought of as a low frequency, right?
Yes. Yeah.
I'm playing a chord there, you know. This one's a chord.
Okay.
It's a major fifth.
Because you got your 1, 2,
One's going
4.
3 while the other one does 2. That one's doing 3, that one's doing 2. And that's a major fifth. It's a chord. And I was explaining this to my friend in Australia, and he found a website, and he sent me an email. Someone's been thinking your thoughts. And this was a musical professor. And he explained, and he went through all the different common rhythms that people used and showed what chords they were.
It's interesting that you can tap out in percussion a chord which we're used to hearing with the different frequencies of notes of different pitch. And you say people are looking at these things. You know, one of those people is Hofstadter, who wrote the book Gödel, Escher, Bach.
It's a great book, I love it.
It's a wonderful book. He will take the mathematical formula of French mathematician Gödel, and then he would take these wonderful drawings from Escher and compare those two to a cantata by Bach. And he would say that you're both having this abstract formula, this visual representation, this sound and music, and guess what? They're all saying the same thing. Wait a minute, you're comparing a picture to a, come on, and then you're going to give me a mathematical formula, and I'm seeing these figures and everything like that. And then he explains that why they're all, and so what he's giving is this wonderful word he uses, it's an isomorphic comparison between them, and that literally means changed form. But it's changed form coming from the same formula.
Did you pick up that he says that somewhere in the book is a false ending, and that after that it's not the same thing?
Indeed.
Yes. And if you look in the index, you'll find some strange things where the page references aren't there. It's one of them is de Boops something or other. And it's quite funny. And you look at this, it's got these two words with a comma in between, and it's got some page numbers, and you look on those pages and that thing's not there.
Interesting.
I worked it out. There's a whole lot of little jokes like this running through the whole things. There's one where he calls it Dogma 1, and he capitalises some of the letters. And if you read it backwards, it's Dogma 1 says, I am God. And he's capitalised the letters to show that that is what he's meaning. There's all these little running jokes through the whole thing. And
nice isomorphic changes.
And there's the Boops one. What it is, George Cantor had his diagonal argument of things, and you had to add 1 to each thing. And what he's done, he's added 1 letter to each letter of the name of George Cantor, and he's added 1 to each digit in the page references, and he's put it in there and that. Now, it's actually got George Cantor in there, so you'll find it anyway. But you have to study this and go through the index and, what is this? And then there's a little joke there. It's George Cantor with 1 letter, and he's done the same to the page number. There's so much stuff like that in that book.
It makes you wonder if such little riddles and jokes are in creation. Dostoevsky said that God is a comedian playing before an audience that's afraid to laugh.